Bismillahirrahmanirrahim. Assalamu alaikum, students. Today we are going to discuss another problem on vectors. Let me write the problem, then we will discuss the solution together. I hope you are enjoying these problems. So let us start. The problem goes like this. An automobile travels due east on a level road for 32 kilometers. It then turns due north at an intersection and travels 47 kilometers before stopping. Find the resultant displacement of the automobile, or you can call it car. So this is our today's problem. So before discussing the solution, let me check the problem. An automobile travels due east on a level road for 32 kilometers. It then turns due north at an intersection and travels 47 kilometers before stopping. Find the resultant displacement of the automobile or car. As you can see, the automobile is displaced twice, so it experiences two displacements. First displacement has magnitude of 32 kilometers due and direction is due east. The second displacement is due north and the magnitude of the second displacement is 47 kilometers. We are asked to find the resultant displacement, so we have to add these two displacements to get the resultant displacement. So let me use some other color. Let us choose a coordinate system. Coordinate system fixed with respect to the earth with the positive x direction pointing east and the positive y direction pointing north as shown in figure 1. So let me draw the figure. Let me use this color. So this is my positive x direction. This is my positive y direction. So this is east and this is north, right? This is my figure 1. So we are taking coordinate system, fix it with respect to the earth, positive x direction pointing east, positive y direction pointing north, and let O be the starting point. Starting point, right? So let A and B be the two successive displacements experienced by the automobile. So A and B are the two successive displacements experienced by the automobile. So A is, let me use this color. So A is first displacement. This is my A. Its magnitude is 32 kilometer. As you can see, the first displacement is due east. 32 kilometer is its magnitude. So A has magnitude of 32 kilometer and it is pointing east. Then the second displacement is due north. This is this displacement. Its magnitude is, this is represented by B vector. Its magnitude is how much? 47 kilometer. It is 47 kilometer due north. So due north means along positive y direction in this diagram. The magnitude is 47 kilometer. So what is my resultant displacement? You can see from triangle law easily my final displacement is from the tail of A to the tip of B, that is this vector, is my final displacement. So I name it S vector, sum vector. So I have to find now S. That is my problem. Find the resultant displacement. So let S be the resultant displacement, right? And let this angle made by resultant displacement with east direction or positive x-axis be phi. So when I say I have to find S vector, that means I have to find its magnitude as well as direction. Direction will be specified by angle phi, and its magnitude I have to find out. So let us find it. As you can see, S is the sum of A and B because it is the resultant. That means Sx is sum of Ax and Bx. Sy is sum of Ay and By, right? Ax, Ay are the components of A, and Bx, By are the components of B vector, right? Now A is parallel to x-axis, that means Ay is 0. Similarly, B is parallel to y-axis, that means Bx is 0. Therefore, what is my Sx? It is Ax. X is the full A, that is 32 kilometer, plus Bx. Bx is 0. So it is just 32 kilometer. Sy is Ay. What is Ay? Ay is 0 plus By. By is the full B vector, which is 47 kilometer. It is 47 kilometer. This is my Sx and Sy. Sx is 32 kilometer. Sy is 47 kilometer. Once I know the components of my resultant vector, now I can find its magnitude and direction easily. Let me use another color. So the magnitude of S is simply square root of Sx square plus Sy square with the values 32 kilometer square plus 47 kilometer square. I solve it. Let me use the next page. The magnitude of S turns out to be 57 kilometer. 32 kilometer square plus 47 kilometer square, then there is square root. When I solve it, it is 57 kilometer. Now, direction of S vector is specified by angle phi, and you can see tan phi is simply Sy by Sx. Let us put the numbers. It is 47 kilometer by 32 kilometer, which is 1.47. So phi is tan inverse of 1.47, which turns out to be 56 degrees. So we have found our resultant displacement. Resultant displacement has magnitude of 57 kilometer and phi angle is 56 degrees. Sy by Sx, which is 47 kilometer by 32 kilometer, then it is 1.47, and phi is tan inverse 1.47, which turns out to be 56 degree. Check, as always, check the calculation at home. So in this figure, this is 57 kilometer long vector, 57 kilometer, and phi is 56 degrees. It is 56 degrees, right? That means the resultant displacement, has a magnitude of 57 kilometer and makes an angle of 56 degrees north of east. Understand it? In the figure, this resultant displacement is making 56 degree angle north of east. It is not due east, but it is towards north by 56 degrees. That's why we say the resultant displacement has a magnitude of 57 kilometer and makes an angle of 56 degrees north of east. This is how we find the resultant displacement using the component method. That's all for today. I hope you have enjoyed solving this problem. That's all for today. Don't forget to like, share, and subscribe my channel. You can give comment in the comment box. Thank you. God bless you. Assalamu alaikum.